This experiment will be found under the module page. In fact, for all work that you guys are going to be doing, if it's not in the module page, then don't do it. The module page is the only page where you guys are going to see the assignment. And here, under week 12, we're looking at the synthesis of aspirin. The first link here, see if I can't do a blow up of that particular page since it's giving you my whole screen. Yeah, actually it's okay. The first page here, if you click on that, will actually give you information. You can download the whole experiment by just clicking on this. And so that's pretty much the whole experiment as found in your lab manual. And then throughout this particular module link, you will see that I've just taken the data section or the pre-lab section or the post-lab question and put it in there. But if you want the whole entire experiment, that's where you'll find it. The PowerPoints are found right here, and I'll be talking about that shortly. Let's go back to the module page. And so after that background information and introductory information, what you have is the quiz. And again, the quiz is pretty straightforward. I'll show you that shortly here. The computer's not acting very well today. Okay, that's this right here, the pre-lab quiz. That's 5 points. And then the pre-lab question is basically the same question in your lab manual. And then the video and the data worksheet. And then this is the link where you upload your data worksheet. And this is the link where you upload your post-lab questions or post-lab answers. And I'm not going to go through the calculations because you guys can do that on your own. What I'm going to do here is just kind of show you, give you an overview of the experiment. So in this particular lab, of course, safety is our utmost concern. And if you were doing this lab on campus, you certainly will need to wear safety goggles. You need to work under the hood and just pay attention to the precautions, especially the chemical handling that's associated with this lab. This is a stoichiometry problem where you have salicylic acid and acetic anhydride, and you combine them, and you get aspirin, which is called acetyl salicylic acid, and then you also get vinegar, acetic acid, as a byproduct. Okay, here are some background information in terms of doing the calculations, because you guys are going to have to calculate the theoretical yield and then your percent yield in this particular lab based on the value that we give you. Okay, so all of this, if you're in my lecture, we did in terms of stoichiometry and dimensional analysis. Here's a little background on aspirin. It actually was first observed in 4 BC by Hippocrates, and he noted that the bark of a willow tree, if you took the bark, heated it up, boiled it, and made a tea, it actually had some medicinal properties to it. Okay, and so you can take a look at this and see about some historical information. Felix Hoffmann was actually the first person who synthesized aspirin, and it was because his father always had a headache, and salicin, which was what was used for headaches back then and aches and ailment, was very acidic, so it upset his father's stomach. And so what Hoffman did was he tried to make, he basically derivatized salicin and tried to make it milder, but still have its therapeutic properties. So all of that is in the background of aspirin. And aspirin, I mean, if you had synthesized that drug and marketed it you'd be a billionaire because that particular drug, more than any other drug, is what is used. Okay. Um, when you get have a headache, your body excretes prostaglandins, and it's the prostaglandins that is responsible for sensation of pain, fever, inflammation, and swelling. What aspirin does is it goes in there and it inhibits the production of prostaglandins, and so you don't get these symptoms. And of course, there are other chemicals out there that does the same thing, and this is like Tylenol and ibuprofen. This next movie you should watch. Um,
What happened next in Germany? There was huge demand for the new headache powders and clearly a fortune to be made by anyone who could come up with an even better drug. Well, here at the Bayer Dye Works, there was a young and ambitious chemist called Carl Duisbeck who decided he would give it a go. Bayer's cellars were full of coal tar chemicals like acetanilide, and Duisbeck set out to see which he could convert into drugs. His first discovery, called phenacetin, was very successful. We now know that, like acetanilide, it's converted in the body into paracetamol. Bayer's factory here grew rapidly on the profits, and so did their ambitions. Another substance they got really interested in was salicylic acid. Now, because it's derived from coal tar, they thought originally maybe it's an antiseptic. They rubbed it on the skin and swallowed it. Unfortunately, it didn't kill bugs like typhoid. But what it did do, if you had a fever, is it brought it down, and it certainly made you feel better. Salicylic acid was effective, but it was harsh on the stomach. We use it now to burn off warts. At Bayer's new drug department, research chemist Arthur Eichengrun thought he could see a way of changing the molecule to make it more palatable. Eichengrun suggested a simple chemical modification, which would in time lead to the production of two incredibly iconic drugs. One of them the world's best-selling painkiller, the other the world's most notorious drug. It started innocently enough. A young chemist in Eichengrun's team set about modifying salicylic acid using an approach that Eichengrun had suggested. The result was crystals of acetyl salicylic acid. Just as predicted, it no longer upset the stomach quite so much. Eichengrun would eventually name this drug aspirin. Simple chemical modifications could clearly make better drugs. Inspired by this, the chemist and the Bayer team took morphine, that powerful painkiller from poppies, and tried the same reaction to see what would happen. The result was a chemical called diamorphine, better known to us as heroin.
so I'm going to stop there. You guys can watch the rest of the movie, but again, it just gives you some historic perspective of
Thank you very much.
aspirin. So let's move on. The rest of this just shows the calculation of how you can take mass of salicylic acid, mass of acetic anhydride, and depending on which chemical is consumed first, figure out the theoretical yield of aspirin. So I think you guys have a bunch of problems like that in this particular experiment. You guys can walk through this exercise if you haven't done so already in your lecture and do the calculation. I'm not going to go through the details here. What I am going to do is illustrate to you that for the synthesis, what you need to do is you need to cool some DI water because you need to, when you crystallize your product, you need some cool temperature bath. You need to weigh out the salicin starting material, and then you need to put in acidic anhydride to that. Sulfuric acid, H2SO4, is actually the catalyst of this reaction. And then what happens is that when you mix all of these, you start to see a precipitate, a white cloudiness that will start to materialize. And then what you do is you isolate it. through something called a vacuum filtration. You guys will see this in the movie when you go further into the lab. This is the filtration process. And I would show you this if we were doing this in the lab, because you probably don't ha- you haven't done this technique, and it's an important lab technique when you get to chemistry 200 and also organic. Anyway, the data table that you guys will be doing is you're going to weigh the mass of a tray, basically a weighing boat. Then you're going to weigh the salicylic acid, that's your starting material. And based on that and acetic anhydride, you guys are going to calculate the amount of, you're going to calculate the theoretical yield. You're going to carry out the experiment and get the actual yield. And then you guys are going to calculate a percent yield. So that basically is the PowerPoint. It's pretty straightforward. And this is a pretty straightforward lab. So after watching the movie, you guys want to take your pre-lab quiz. And this is the pre-lab quiz right here. Let's take a preview real quick. Again, you guys have 10 minutes, multiple choice. Um, Here are the 5 questions, and it shouldn't take you more than 10 minutes at most. After that, you guys will go back to the module page and answer the pre-lab question. And the pre-lab question is the same as the question in your lab manual, except of course, to make grading easier, I put it in a format where it's a multiple choice or a matching. Okay. And here, you guys are going to need to put in the answers when you do these calculations. So that last question is involves synthesis, where you're asked to calculate the moles of salicylic acid or salicylic acid, the mass of the acetic anhydride, and then calculate the moles of acetyl anhydride present, and so on and so forth. Okay, so this is your pre-lab question. And again, it's sort of modified so that the grading is much more automated rather than turning in that particular pre-lab before class starts. Remember that this experiment is due by Friday. So if you guys can start it today or by Friday midnight, you need to get that in. Once you finish the quiz and the pre-lab, then you can look at the data sheet. And let me just introduce you to the data sheet and the video. And here you can see that I put it in this table. If you just click on this triangle right here, it'll open it up, or you can just click on this and then it'll open up into a new page. But it's basically just the experimental procedure for the synthesis of aspirin. This next video over here, let me stop that, is adding iron chloride, and this just sort of verifies the purity, or it just verifies a test for aspirin using this particular reaction. Finally, this particular video, and these videos are not long. The first one is 5 minutes, the second one's about less than a couple of minutes, and then the last one is 3 minutes. So watching this video is less than what?
This machine is going to check the
less than
purity of aspirin.
10 minutes, okay? As opposed to 3 hours in lab. Let me quiet that. So you want to watch these videos, and then you want to write your experimental observations based on what was happening in the video. Then you want to use these data. These are the data that you guys are going to be using for your calculation. The mass of the weighing tray, the mass of the weighing tray plus salicylic acid. So you can figure out the mass of the salicylic acid. You guys are going to put this in your lab manual. The mass of the filter, the volume of the acetic anhydride. This is basically, again, the data that you would have written down in your lab notebook had you done this experiment, the drops of sulfuric acid. In terms of the product, you guys are weighing a watch glass. You're putting the aspirin on with the filter paper on the watch glass, and then you should be able to calculate just the mass of the aspirin that you synthesize. Based on the actual yield and the theoretical yield, you guys should be able to calculate a percent purity. Then watching this last video, make sure you write down information about the purity of your product or the purity in that video. That pretty much is it in terms of this experiment. If you click on this right here, it'll give you a preview of the data sheet that you guys are going to be completing. Make sure you complete it. Take a picture of this. Don't put it on um, a scratch piece of paper. Make sure you write it in your lab notebook directly or print this out and then submit this. Okay. This is what I'm going to be grading. I'm not going to be grading straight pieces of paper or notebook paper. Then when you're done completing this, there's a link in the bottom here. If you turn this in, you could sorry, not this page, but this is where you would get that information. Let's go back to the module page. And in the module page, you will see the link to turn in the data sheet. Remember that if you have more than one page, you need to put it in a folder and then compress it or zip it. It gives you instructions right here, I mean. But this is the page where you guys are going to upload your file. And then finally, the last um, link here is where you would upload your post lab. Make sure they are separated. Don't upload both on one link here. That way the grading is easier for me. You click on that and then you upload your post lab questions here. And I remind you again that if you have multiple pages, you need to put it in a folder, zip it, give it an appropriate file name, and then upload it here. So that's your experiment for this week. Pretty straightforward.